Now let's look at rules of differentiation. The first rule that we are going to discuss is addition or subtraction rule. If y is equal to u plus or minus v, if y is in this form, u is a function of x, v is also a function of x. It means, suppose if you have y is equal to, say, x plus sin x. This is u, this is v. These two are two different functions of x that are being added to get y as a function of x. Or y is equal to x square plus 2x. So y is in this form. Here u is equal to x square, v is equal to 2x. So if you have y as sum of two different functions of x, or if you have y as difference between u and v, addition or subtraction, then dy or delta y, whatever, dy is equal to du plus or minus dv. If y is equal to u plus v, change in y is equal to change in u plus change in v. If y is equal to u minus v, change in y is equal to change in u minus change in v. That's what we are writing here. Okay. So change in y, because y is equal to u plus v, change in y is equal to change in u plus change in v. Because y is equal to u minus v, change in y is equal to change in u minus change in v. That's what we are writing. Or we can write dy by dx, change in y by change in x. A little bit of change in y by little bit of change in x. Infinitesimally small change in y divided by infinitesimally small change in x. dy by dx is equal to du plus or minus dv by dx. We are multiplying with dx for obvious reasons in the denominator. dy by dx. Now split the right hand side terms. You will get du by dx plus or minus dv by dx. This is called addition rule or subtraction rule. dy by dx is equal to du by dx plus or minus dv by dx. Let me discuss one simple example. Let's take y is equal to x square plus 2x. Y is equal to x square plus 2x. We want to calculate dy by dx. Okay, so du by dx plus dv by dx. U is x square is u there, 2x is v. Okay, we are applying this addition rule. To calculate dy by dx, you can write it like this. So dy by dx is equal to dy dx of x square. You know, x to the power of n formula we derived in the class. D by dx of x power n is equal to n into x power n minus 1. So this is equal to 2 into x to the power of 2 minus 1. Now look at the numerator here. The numerator is change into x. Change into x is equal to 2 times change in x. Change into x is equal to 2 times change in x. So here dy by dx is equal to, this is equal to 2x and this is 2. The first term is 2x and the second term is 2. dx by dx is equal to 1, you know that. So dy by dx is equal to 2x plus 2. This is how we calculate dy by dx by applying addition rule. Now let's discuss multiplication rule. Let's look at multiplication rule. If y is given as a product of two functions of x, u is a function of x, v is also a function of x. Let's look at an example. Y is equal to x log x. This is product of two functions. Or y is equal to x square into tan x. This is product of two functions u and v. Or y is equal to, say, x square into 1 plus x whole power 10. This is also product of two functions u and v. In such cases, we use the multiplication rule to find dy by dx. This is very simple. If y is equal to u into v, y plus dy is equal to u plus du into v plus dv. Y plus dy is equal to u plus du into v plus dv. Or we can write y plus dy is equal to multiply each term in the first bracket with each term in the second bracket and expand it. You can write this as uv plus u dv plus v du plus du into dv. Du into dv. Well, you know y is equal to u into v. So y and uv cancel out. Y is equal to u into v. Du is infinitesimally small. dv is also infinitesimally small. Since du is infinitesimally small and dv is infinitesimally small, their product is negligibly small. The product becomes negligibly small. So we neglect it. When compared with these terms, this product becomes very, very small. Okay. So if you neglect that, you will have dy on the left hand side, u dv plus v du on the right hand side, dy by dx. Now divide with dx on both sides, u dv plus v du by dx. Now split the terms on the right hand side. If you split the terms on the right hand side, you can write this equation as the following: dy by dx is equal to u dv by dx plus v du by dx. This is the multiplication rule we use when y is given as a product of two different functions of x. Let's see a small example. Let's discuss a simple example here. I'll take y is equal to x square into sin x. X square is a function of x. Sin x is a function of x. So x square is u, sin x is v. Okay. Then apply this multiplication rule. Y is equal to u x square dv by dx. So that is d sin x by dx plus v. V is what? Sin x into du by dx. That is d x square by dx. Now this is dy by dx. dy by dx is equal to x square into d sin x by dx, we know. D sin x by dx is equal to cos x. We know this. Plus sin x into dx square by dx, we just calculated in one of the previous examples. So dx square by dx, apply x to the power of n formula, you will get 2x. So this is it. So we calculated dy by dx here. So dy by dx is equal to x square cos x plus 2x sin x. This is how we calculate dy by dx using multiplication rule. The next rule that we are going to discuss is division rule. Let's look at division rule. Y is equal to ratio of two functions of x. If y is given as a ratio of two functions, I'll give you an example. Suppose if y is given as x square by 1 plus x. The numerator is a function of x, denominator is also a function of x. Numerator is u, denominator is v. Okay, or y is equal to sin x by whatever, cos x. Let's say we are finding the derivative of tan x. We can write it as sin x by cos x and apply the division rule. So numerator is a function of x, denominator is also a function of x. So how do we apply the division rule? We know y plus dy is equal to u plus du by v plus dv. So when u changes by a small amount, v changes by a small amount, y changes by a small amount, this is the relation we write. Y plus dy is equal to u plus du divided by v plus dv. Now the same equation can be written as y plus dy is equal to u plus du into v plus dv whole power minus 1. V plus dv in the denominator can be written as v plus dv whole power minus 1. Now what we are going to do is, we take u common in this term and v common out in this term. So u comes out. This becomes 1 plus du by u. Here v comes out, v power minus 1, this is 1 by v. So 1 plus dv by v whole power minus 1. Now that equation can be rewritten as y plus dy is equal to u by v into 1 plus du by u, 1 plus dv by v whole power minus 1. You know, binomial expansion we discussed in one of the last classes. 1 plus x whole power n is approximately equal to 1 plus nx when x is very small. When x is infinitesimally small, 1 plus x whole power n is equal to approximately equal to 1 plus x. So 1 plus dv by v whole power minus 1, because dv by v is much smaller than 1. Here we wrote this. When x is much smaller than 1, we said this condition is valid when x is much smaller than 1. Here dv is much smaller than v, it means dv by v is much smaller than 1. So So 1 plus dv by v whole power minus 1 is approximately equal to 1 plus nx. N is minus 1 here. So 1 plus minus 1 into dv by v or 1 minus dv by v. 1 plus dv by v whole power minus 1 is approximately equal to 1 minus dv by v. So let's write 1 minus dv by v here. Now multiply the right hand side terms. You will get u by v 1 plus du by u minus dv by v minus du into dv by u into v. This is what you have, or this is y plus dy is equal to u by v. Take u by v inside. U by v plus u by v into du by u minus u by v into dv by v minus u by v into du into dv by u into v in the last term. Last term is negligibly small. In the numerator, du itself is a small number, dv itself is a small number. This is infinitesimally small, this is also infinitesimally small. The product becomes negligibly small. Now you know y is equal to u by v. Y and u by v get cancelled. If y and u by v gets cancelled, here u gets cancelled. You can write this equation now as the following. Dy is equal to du by v minus u dv by v square. This term is du by v and the second term is u dv by v square. Take LCM and simplify. You will get dy is equal to v du minus u dv by v square. Or you can write this as, if you divide with dx on both sides, dy by dx can be written as v du by dx minus u dv by dx by v square. This is the division rule. Division rule is dy by dx is equal to v du by dx minus u dv by dx by v square. So these are rules of differentiation. We discussed addition rule, subtraction rule, multiplication rule and division rule. Okay. So we did not just write the rules. Okay. These rules are logically derived from mathematical concepts. Okay. This is all mathematical logic. We have not done anything from our memory. Okay. So following the mathematical logic, we derived the expression for dy by dx if y is ratio of two functions. Similarly, even in the multiplication rule, even in the division rule, we followed that mathematical logic to come to these types of conclusions.